So you're a professor at Berkeley, and there you co-founded and co-direct the Rise Lab as well as SkyLab. So tell us about these research labs and the problems that you're tackling.
Absolutely. So I'll tell you a little bit of how, I'll start by saying how the Berkeley labs are structured, because I think it's a very unique model. Um, so basically, every 5 to 6 years, some of us faculty group around what we think are the big problems to solve in, computing systems. And that gets a lab and a lab name. And there's a lot of industry companies that are supporting us and collaborating with us, giving us feedback about what are the major problems they're seeing. And then we incorporate that in our research. So the Rise Lab had just come to an end 5 years ago. It was really focused a lot on um, cloud computing, security in the cloud, and machine learning in the cloud, but in one cloud. So outcomes from that were prominent open sources like MC2 for us, which that's confidential computing and is the basis of Opaque. Also Ray, which you guys might have heard of and is the basis of Anyscale. So now we regrouped again and to create a new lab, the SkyLab. And really, the major problem we kept hearing a lot from industry and around is the fact that the world is becoming cross cloud. So, not just one cloud as we were in the Rise Lab, but cross cloud. So, going from the cloud to the sky. That's why it's called the SkyLab. So, there's companies have pipe, they don't want to be locked into any one cloud. And there's a lot of cross cloud applications these days, lots of companies cross cloud, but also because different clouds have different strengths. For example, Google has the TPUs, right? Or Azure has excellent confidential computing. So different parts of your pipeline might make sense across different clouds. So what we try to do in the SkyLab is we're trying to enable that sky computation so that users and organizations can just run their pipelines in the sky without having to develop complex systems for which part goes on each cloud and trying to decide which is the most cost effective or the most performance effective way to optimize it. We do all of that. We basically schedule each component in wherever they should go. We optimize the cost, we optimize the performance, and we take care of the security cross cloud. So that's basically the big research thrust and the work we're doing right now in the SkyLab at UC Berkeley. And obviously, a big part of that are also, generative AI supporting that in a very efficient way in the cloud.
That is fascinating. So first of all, I didn't know about that Berkeley lab structure, but it doesn't surprise me because I've noticed when I am researching for guests at Berkeley, or just there's so much exciting research that even before I was a podcast host, I was frequently looking at things that were going on in Berkeley AI labs in particular. And it seemed to me obvious that there was a huge amount of collaboration. Like you see
Absolutely.
different co-directors, prominent AI people working together. I didn't know that they had these kinds of, I don't know if you would describe it as like a mission to like kind of accomplish over a
Yes,
certain number of years. Yeah.
yeah, it's a mission. We're all united in the lab for a mission. And we have, for example, the SkyLab has professors in machine learning and systems and in security, because to accomplish a mission, you need to cover all of these aspects. Yeah, I think the lab structure is incredibly exciting. The way Berkeley managed to make it work, it has a huge track record. If you think about it, from our labs, Spark came out right in from the AMP lab. That was 2 labs ago. Or we have RISC-V or RAID or all these big open source projects. Again, the labs are about creating open source that has an impact and changes the world. Honestly, that was the kind of sexiest thing that attracted me to Berkeley when I finished my PhD and I had faculty offers, MIT, Stanford, Berkeley, and a bunch others. I just loved the lab model so very much. It felt like the right synergy of industry collaboration research really coming together.
Yeah. Fantastic. Seems like a great choice. I've never been to the campus, but it seems like a beautiful place, a very collegial environment.
You should come visit.
Nice. Yeah. And long overdue. Um, okay, so Skylab, it's focused on efficient, seamless compute pipelines across multiple clouds, taking them into the sky. I like that clear example of like maybe you'll want to use Azure for confidential computing, GCP for their TPUs. And so these different advantages of the different clouds, you can leverage all of those as an end user as you're developing your compute pipelines. So that makes a huge amount of sense to me.
As well
Um,
as smaller clouds. So the nice thing about it is that there's a lot of innovation in the smaller clouds, but they tend to be specialized at one thing, right? Or a very few things. They're not like Amazon, AWS, which is so general, has so many offerings. It intends to be kind of like a one-stop shop. And this really encourages also the innovation in the smaller clouds and just smaller deployments.
cool. Yeah, I hadn't even thought of that. I don't. Yeah, it's so bad that the big players are so prominent that I spend an embarrassingly small amount of time thinking about the smaller players in the space.
Exactly.
Like in my mind, it's like, what's a small player? It's like the Alibaba cloud is small.
Yes, yes, yes.
um,
IBM is smaller as well. And
I guess so, yeah. But even those are huge.
yeah,
I'm sure
yeah,
there's for
yeah.
specialized use cases, there must be so many. There's probably hundreds or thousands of different cloud providers. You had specific, before we kind of transitioned over here, you said a
Yeah.
really fascinating specific topic. What was that?
I would say that some of the smaller clouds are also these mining pools, or like this big, this
Oh, yeah, all the spare
blockchain nodes
compute,
that used to, yeah, all this spare
the
compute
spare
is like
compute.
used to be specialized just for blockchain, but now there's thoughts of repurposing them for LLM, and that's also really exciting. Yeah, actually, speaking of small clouds, there's some also very interesting compute resources that are available in the blockchain world. As you know, there used to be this proof of work where you mine and spend a lot of compute to win some reward. But now a lot of the big blockchains, for example Ethereum, they moved to something called proof of stake, where you don't need to do that compute anymore. It's all based on something completely different, based on how much stake you have in the system and things like this. So now there's all that compute available, and there's mining pools, and so they're like little, you can think of them as little clouds, and there's all that compute available, and it's set up to work for some reward and for some goal. And then a very interesting research question we're looking at is, how can you repurpose those for training LLMs or for inference of LLMs, right? Those nodes are extremely good at, you give them a task and they get the reward for what they're doing. And in fact, in the blockchain space, there's also this very interesting structure called slashing, where they put some money in themselves, and if you find that they're doing something incorrect, you basically get that money, kind of like an insurance. So it's a really nice. Now, the challenge there that my students and I are thinking a lot about is, because it's not a major cloud provider running this computation, but it's lots of small people operating it. How can you trust, right? How can you trust that they're doing this training correctly, training a model correctly, for example? And because you have a huge computation, you give them different pieces, how can you trust that? Um, and yeah, for example, you could say, let's say multiple nodes could run the same computation, but then again the cost will grow. Right now there's actually some running estimations, that if you have the compute run by these nodes, it's actually going to be cheaper than the clouds, because clouds charge premiums and GPUs are expensive in the cloud. You're actually going to get it much more efficient, much more cheaply with these nodes. But the problem with these nodes is that it's a bit the trust, right? They're so different operators from all kinds of different places. How do you know that they're doing the right thing? So that's a very big research challenge, one that we're thinking about in the SkyLab.